Janvi, can you see my screen?
Yes.
Perfect. Okay. Good. Today's lecture will be maybe the final lecture across the content of the course. So today we talk about testing. How we can perform a testing and evaluation about a system that you have already make an analysis and design before. And after you made this analysis and design, you have already implemented it, and now you want to double check if this implementation was expected based on the requirement and specification of the system. And the week after will be the last week. So I will be live, but I will keep it open for the group that they will make a live presentation during this. As I said, that it is a must to make the project presentation. So either you will join us in this live session if you have time, you are the group, or you are going to make an offline presentation, or not offline, maybe it will be online between each of you, but however, it will be not during the live session, and then you are going to share the video with me. And the deadline will be also, in this case, the next week in this case, which means that 6th December. So 6th December is the outline to send me the presentation, to send me the final delivery of the project. So you have 1 week more. We should take care for this. And maybe also the next week we can have presentation if there is somebody has to make the presentation. And maybe we can talk about some hints about the structure of the final exam. Because I start preparing the final exam. I haven't done so far, but maybe for the next week I can have a final image about the final exam, how it's going to be. So the last time we have already reviewed some OOP Java programming concepts, because even though it is out of the scope of the course, but as I said the last time, it was nice to review this, because you need to understand more how you can make the mapping between the design that you have so far have done with the implementation. Again, the main core of this course is about to perform analysis and design, and somehow we have already done with this. But even though we have done with a design using design class diagram and state chart diagram, and we have already finished before with different interactive diagrams. And before this, we have the analysis when we talk about business modeling and requirement structuring. However, it will be somehow not so practical if you can see how this was the mapping between the implementation and the design. And today, I see that you should know also about the testing, how it can be done. This is why we are here today to have this lecture about the testing and evaluation. So today we'll talk about general what mean by testing, what is the general objective of testing, and then what's the meaning of the testing and different definition for testing. And we talk about test phases, which is 2 main phases, unit testing and integration testing. And during this, we will talk about object-oriented specific testing, which means that how we can perform a testing for a program or a software or a system that was based on object-oriented analysis and design. And for sure, when we said that it is based on object analysis and design, it is there is a high probability that the code also should be also object-oriented and design, because if you are object-oriented programming, so if you have already done the analysis and design based on object-oriented, you should continue this methodology and you use it in your own implementation in this case. The testing definition, that's when we define what is testing. There's many definitions for this. all of us, even though we are not so far familiar with how we can make this testing, when we said testing, it's all of us will come to our mind, bugs and error, how we can find it. So testing is somehow go ahead and search where the bug and errors. However, yes, it is how I can find where there is an error and where it is also some bugs with the system. But this doesn't mean that I have to go make a trial and error testing, which means that I'll go ahead and run the system, and then I have an error, and then I will double check. It's not like this. There should be a procedure and checklist to be sure that different aspects and different content of the system is being well done based on what we have already carried out the specification and the requirement. So it is a process of executing a system with the intent of finding error. So we will not go ahead and make a deployment for a system and a release and give to our customer without having this internal testing that should be done. Sure, for sure there will be always that, like we see in most of the software, that whenever there is a crash or a bug happen, there you give the option for the user to send you a feedback to consider this feedback in enhancing your system. However, when you talk about this testing, what we will want to discuss today, we are talking about the testing and evaluation that should be done by us as a developer before we execute the final version to the market or to the customer in this case. So, but by the way, this is the word of Edgar when he said that the program testing can be used to show the presence of bugs, but never to show their absence. What this means that when you start making a testing, you have the intent to find a bug. You will do your all best to find a bug. You will not go ahead and do it in a way that if there is some errors or if there are some misunderstanding of the requirement, that you can feel that this program doesn't fulfill the requirement that was built for this, doesn't mean during the testing we have to hide this. No. This is why most probably the people or the personnel that is going to make the testing procedures should not be the same people that they have already made the analysis and design and the implementation. Because normally, if you make you are a part of a person that you have already built this software, it will be your own baby. You will not make a huge effort to do double check where there's a bug. Maybe sometimes you want to be sure that the cycle is being executed correctly without taking the whole test cases or the use cases in consideration. So this is why we always have to have another team that is going to work in testing, not the same team who had already made the development and before this, the analysis and design for the system. It is very important in order to show the presence of bugs if there is, but never show their absence. When we talk about a bug, doesn't mean that only we have an error like crash. Sometimes the result that we receive from the system, it doesn't fulfill, again, the requirement that we have already considered at the beginning during the analysis of our system before we start implementation and before we start design. So, okay, so testing in this case should be based on a well-defined quality control. When we talk about a quality control, means that there is a checklist. What I mean by checklist, that based on the hierarchy of the system and based on the structure of the system, that you should have already a documentation for the structure. documentation for the structure. Yeah, this is a design that you have already done. Different diagrams that you have already done, design class diagrams, state chart, object diagrams, the use cases and the sequence diagram, they all make a documentation about the structure and the behavior of different components of the system. So based on this documentation, you should have already created your internal audit to double check that all use cases that being already defined at the early stage, the system is giving the output result as being planned before. So when we talk about this, it is the last point is the production line, mean that we are still talking about production, mean that the product is not now in the market. So you are in the early stage where you are going to evaluate your system before it will be a release version to go to the market. Again, it is not the same when we talk about sending feedback from the user later when there is a problem happen with the user that we didn't consider during the testing or evaluation. So testing that we are talking about today, it is part from the production line, which means that it is a standard procedure that should be done after the implementation that had already been done. And this standard procedure, as we will see, they are based on the different design deliverables that we have already developed before start implementation. So the objective, as we have already said from the beginning concerning definition, is to uncover as many errors or bugs. We will talk now later more in the next slide about what we mean by different errors and bugs. And this is what I was saying, that demonstrate that a given software product match its requirement specification. When we talk about requirement, we talk about use cases and scenarios that we have already defined at the beginning. Because as we said, the use cases and the scenario talk about the outer user of the system, how they will leave the system, what different actions they will do, and what different results they will get. So the specification is based on the requirement. The requirements are based on the use case and scenario that we have already collected as a beginning before we start implementation. And it will be part of about quality control report or evaluation. So when I will go to the market, I will say this is a test report that I have already done. This will also help me to promote my software. That this software is being already tested for this case scenarios. So people, they have more trust on my product in this case. Especially the customer that I have already, if we are not talking about generic software, we're talking about customized software. So I should deliver this with the final release version, which is the testing result that give a high impact for concerning the trust of my system. When we talk here about testing objective, when we talk about uncover as many errors or bugs as possible in given time, so when we talk about error, as I said, it doesn't mean that only that the error which there is a crash or, for example, systemic crash. No. So I have to double check that if there is a gap analysis between the requirement and what is already done so far, all the requirement being satisfied. So maybe sometimes I have also problem with understanding of the design documentation, because the design documentation talk more about the design as well, the system specification. So all the system specification is being mapped with the documentation. And is this documentation is somehow mapped with the real case scenario that we have already agreed before? And what about the system resources environment? And finally, sometimes we will have incompatibility between the hardware and the software. That at the beginning, you have already agreed with your client that this software needs this capabilities as a hardware. If it really can work probably with this hardware specification that you have already asked the customer to have it. So this is all should be considered while we are making this testing procedures that we are talking about. So who will be the testing personnel that will take care for all these testing procedures? So again, normally there should be a testing unit if you are talking about big company that they make high scale software that need to have sophisticated testing. If you remember, the first lecture in this course talk about the software disasters that happened during the history. We talk about three to four examples about a big disaster happened because of bugs in the system, like the aerospace system, the European one that make the crash after seconds or minutes of being already released, and how many money they have already lost. And sometimes there will be life also lost in this case. So this is why testing should be done by specialists that know how to make this testing procedure. And sometimes we will have a testing department, a test engineer, when we talk about high scale and high volume software. The testing, if we talk about the department, then should we have a manager for this? Again, it depends about the scale of the companies that developing this software. So we'll have software engineer or testers. So we'll have development software tester, engineer or testers. They develop the test cases. Somehow these people, they should be more familiar with the analysis and design. They know how to deal with different UML diagrams. They can understand the UML diagrams, and they can understand more about how they can develop a test case. We will talk now before about test case, but test case, which means that based on different scenarios, what is the input and what is the expected output? This should be declared and defined for the different test cases that we will have. Like when we defined at the beginning use cases. We said use cases or scenario. Here we have defined test cases, which means that having different input or different modules or different units or maybe set of units, we will talk about it later. So the test cases definition should be done by a software test engineer or testers. Who will perform this should be a development engineer or specialist, because he has to know how to deal with the code. So software test engineer should have a good experience with the code. However, doesn't mean he has to deal with the code itself. The same when we make the development. So there are a system analyst who has already developed the analysis and design, but doesn't mean that he has to write the code. Somebody else has to write the code based on the analysis and design that the system analyst has already done. Here, so the software test engineer should be something very similar to the system analysis, and the development engineer or the specialist will be very similar to the developer that already writes the code. Based on the test case, this development engineer or specialist is going to make the development of the unit tests and integration tests. We will talk about it later. Sometimes, but it is not always we will have a quality assurance group. And it is a must to have when we have a high volume or high scale software. This will talk about the system as a whole. They will not go to make a testing for different units. We will go ahead to see the system as a whole based on the initial input and the final output, and somehow we'll talk more about the system structure with the hardware structure that we have already developed. If everything is okay, yes, no, and the quality concerning the efficiency now, it's somehow based on what we had already planned before at the beginning when we make the use cases. And sometimes we will have independent testing group, and this will be very specialized, based on very specialized need or based on something change in the environment or our ecosystem, so we create a temporary testing group in this case. However, I can see that the two main part in this is a software test engineer, a software engineer or specialist or software specialist. The first one will take care about developing the test cases, and the second one will take about the performing of the test in the unit level and the integration level. Integration level, we'll talk about it later. We mean that it is an upper level when we have more than one unit within this package. Test activities. So what is different activities we will have? Planning. Who will take care of the task manager, which means that when you talk about planning, we talk about test cases plus time schedule and different resources management. The test design specification, we talk more about the test cases also here, because as we said here, we talk about test cases. So the cycle of the activities will be like, after we have our test case, that we have this scenario, we have this input, we have this data, we have a driver module, we go ahead to make this unit test and the integrated test, and then we will have an error, we will create the error, we double check the result, and then we will go to make a repair, and then we will make a repair and a repair error, and then we will make retest again. So this is a cycle of the activity that we are going to do for testing. So let's start with a test case. So we said that at the beginning we have to design test cases, and then we will go to perform this test. Normally there are two main methodologies in the test case, the black box and the white box. Black box, which means that if you are testing a component, when I said a component can be a unit, which is a class, or maybe a method or a function, and it can be more integrated, which means it can be set of classes or packages that you have to deal with it, whatever it is, which component we are, or maybe we are testing the whole system in this case. So in this case, when I said a black box, for me, this methodology of test cases, I'm developing a test cases that will not go to specification, which means the internal specification of the system. It talk about more general about I deal with this component. Again, when I said the word component, it can be a unit, or it can be a package, or it can be the whole system. So I have to deal with this component as a black box. I will not take care about what's taking place internally. I would take care only what's taking place, what is the input that I'm giving, what is the output. And based on this test cases, this input is what will be based in the use cases that I have it as a beginning. And do I have the output as expected? Yes, no. The white box, no. The white box, no, I have to go internally to follow up the development, the execution cycle internally in this component. Is it done based on the design that I have already done? Yes, no. Because sometimes, even though you will have this result that you expected, but there is a bad efficiency, which means that there is a delay. And this delay will be because of there's a mismapping, or there is a gap between what is already designed and what is already implemented. And this gap may be sometimes not because of the design, maybe with a misunderstanding of the design. And sometimes because there is an error on the design. This depends now how you locate the error and where it should be solved. It should be solved in the design, then go to implementation, or the design, if it is correct, then there is a problem with the implementation in this case. So we said we have two methodology, white box and black box. So either we go internally to see the execution different functions, this component, or we will deal as the input and output without going internal. This is the two main methodology and mostly used methodology. Sometimes we will go to test cases like the black box. So either we said we will go not like having this white box or black box. We call test tool specification, which means that it is more like black box one. However, we will go with the functionality, but however, in a higher level. We will go to the main functionality and very generic function, that's going deeply in the functionality in this case. What about test to code? Here in this test to code, we will not consider anything about specification. We will start with the code itself. And people who has to do this, they don't have any pre-knowledge about the early specification of the system. And they have to create their own dummy data or driver module. However, it's best that this data that you are going to use, it should be based on general specification according to what has already been designed before. So going to the white box, it's better than go to this, what they name it here, glass box, because the white box talk here about more about that I will make a data, which is the driven data, or based on the driver module that we talk about it. However, this data, I will collect it based on what will be specified. Not only go ahead, see this code, I will generate a data for this and go double check this code to be sure that this code is executing based on the data that I have already given. But now there is a big question. This data you have already collected based on what? So you should consider the general specification of the system when you are make this data warehousing and collecting this data before you will use this data to go to the code and double check that the internal functionality of the system is working probably to this data that you have already chosen. So we talk about object-oriented structure. From the beginning we said this course is for object-oriented analysis, object-oriented design, and also object-oriented implementation later. Even though we didn't talk about object-oriented, we talked about very generally, just one lecture, how we make this mapping between the design and implementation. So if we return back to this object-oriented analysis, so we have a use case analysis, we have in the design, we will have a class design, and then we will go to the implementation based on this design class diagram with other resources. We will make the method design and then implementation in this case. So here, this is very, very important to understand. So if you are testing the function in a class or a class, we are testing the unit. If you are testing set of classes, it's no more talk about integration testing. Cluster testing, it's somehow here, it is in the gray zone. Some people will say, okay, cluster testing can be seen as a unit testing, especially when we talk about a pair of classes or classes that have inheritance. Some people, they have talked about like this, but some people know, we said it is, when we talk about unit testing, talk about one class. So it depends about different understanding about what you mean by cluster testing. So, but normally, in the mostly used, when we talk about cluster testing, which is, we talk about more than one class, it can be two classes, or it can be more. So we are talking more about integration testing. And when we talk about also the use case testing, we talk about integration testing. So we will have, as we said from the beginning, we have two testing, unit testing, we talk about low level, method and class, and we have integration testing, we talk about cluster testing or set of classes, and use case testing in this case. Let's start with the unit testing now. So unit testing can be for method or function, class, and sometimes class cluster. As I said, sometimes it can be class clustering, but it's I keep it like this, that sometimes when we make some references, they will refer to it as a unit test based on their own definition, especially when there is inheritance between these classes. But as I said, the more generic or more general, that class clusters will be under integration testing. We can see it as integration testing, not as a unit testing. But however, when we talk about a special class, or we talk about a method or a function and class, we are talking about a unit testing. It can be by development engineer or development specialist, as we said, is to test the unit performance. We are not talking about the whole system, this unit. And when you develop the test cases, these test cases that you have already developed, you should have already, this is concerning planning, that this test cases, how many unit is being involved in this test case. And then we will go to each unit, each alone, and then we will go to the integration to see set of this unit, how they are working with each other. So there should be a checklist. Now I have a unit, I have a special class or a method. I want to test it. So first you have to double check the interface. We know what is interface. This is the interface that the user has to deal with it when he has to deal with this class, if you're talking about a class. And sometimes about a method in a class. The data structure. You have to double check, you make a checklist, the data structure for this method of a class. It's based on what we have already defined, yes, no. Boundary condition, which means that if you remember, this is, it can be worked probably as a boundary in this case. Or most probably, always you have a control structure. Loops, if else condition switches. So all these passes are executed correctly, yes, no. And you know that there is always error exception, error handle should be considered during the implementation. All of you know this. I'm not talking about the error that we will find it now. I'm talking about the exception error handling. That, for example, if it's a very simple one, if you want, you are make dividing, you have assured already. If you are making a dividing, you should, for example, use dividing within your loop. So you should be sure that there's mode definition as zeros, and there you have to handle it. Or if the user put an enter that is not based on what you have already defined, or there will be an error handling, and then should be send a message for this user. So we are talking about here the error handling that was already defined in the system before, again, before we are searching for the error and bugs that we will find during the testing. Because always in our code, there should be error handling. You are connecting to a server, and you should consider that there is a problem with the connection, that there should be an error handling within your code. If there is no, before it will continue your system. So at the beginning, if there is an error connection with the server, there is an error handling the return back and set for the user, no connection with the server. So now we are talking this error handling code. It should be within the checklist for this unit if there is an error handling in this unit that we are dealing with it. Yeah, as I said, that you should have already defined the test cases before you go ahead to the yeast unit, because this unit should be apart from a test case. The driver and the sub. So a driver, it is a data source, which means this is a module that will give me the data that based on this that I will make this perform the unit test. And a sub, it can be like here, it can be a dummy or temporary implementation that I have to check the result using this temporary implementation. Why we should have this stub? Because normally this unit in our system is not a standing alone. Let's see. Okay, let me give you a real example. Suppose you have a class. You have function A, function B, function C. And we want to test this function. So our unit test is a function itself, not the whole class. And normally when you are going to call this function in the class, you will call function A, and the output of A will go to B. But now you are going to test A. So in order to get the result without calling B, so in this case, you will create a dummy output for A, which means printing print the return value of B, print it out. Even though in the your system there is no printing out for this value, because this value will go to another place in the system. But you are testing now, this is a system on this unit only. So you will make this temporary dummy output just to double check the result of this unit based on your checklist. This is what I mean by stub in this case. So stub, it is a dummy piece of code. We use it to get the result of this unit, to double check the result of this unit. If the result of this unit was not printed out for us and according to the initial code of the system. As we said, when we talk about object-oriented, we are double-checking class-level testing. So either the method or the whole class, when we talk about unity class testing in the object-oriented environment. So when we talk about object-oriented, so we talk about a precondition and postcondition for each class, each method, and for all this method should be within a class is being already defined. And if it is public one, so we can use a black box approach, because in this case, we'll go to this function, if you talk about a function, and then we will send the argument for this function, and we will double check the output for this function. We will not go to the code, because if it is public, we can execute it and easily from different places. However, if we're talking about a method or a class that is already being private, and in order to execute it independently from different places, so in this case, maybe for testing issue, we will change the access control of this unit and from public to private in order that we can access it, because we know that in object-oriented, we have different access control for different component when we talk about a variable or we talk about method or a class. We are testing either a method or a class. So it can be protected, private, public. If it is public, it's easier to do it. If it is private, there is many restrictions how we can call this method. So for testing issue, as we have already created a stub that to get an temporary output to print out to double check the output. Also, we can change it temporarily from public to private, from private to public, in order that we can execute the testing for this unit that we are talking about. So we have a state chart. We can create a test cases per state chart. So for us, starting from this state chart, I can start creating or defining my test cases. That each transition, if you remember that each transition, the test case is, each transition, if you remember, it is, we have an action and we have an event. So action, which means the execution of this functionality, and the event, and what is the output that will be based on this, what is the execution that will happen after the action being already developed. So I can create test cases per transition in this state chart, whatever, any state chart. So I will not start from the code and go double check each code, because this code is being already implemented based on different documentation in the design stage. So I have to double check first that in this design, and that I had already done, that each stage is being already developed. And according to the definition that or declaration that take place at the design level, that this transition expected based on this event to do this action. So I will create the test cases. And then based on this test case, I will go ahead to this unit that is related to this transition, and double check that this unit, I'm talking about unit testing. So I want to double check that this unit testing is somehow has already executing the whole code based on this transition declaration and give me the output result that I had already expected. So, for example, possible test cases from this, if you remember this, we have this state chart we have already used before in our system. We have already used before in the example when we talk about implementation map from design to code. It's about the account stage part. So here we can create different use cases, test cases for the unit test test level. Like here. So here we have a transition talk about deposit and transition talk about withdraw. And as we have already discussed before, this should be methods in our system. So if we can see that this is a possible test case, this deposit and this withdraw, an integer. And here, deposit 10, withdraw, and what we will have deposit 5. So we will take this as test case. So this test case tell us about what expected, what is the input that we expected, and what is the result should be expected. So this is, each one of them is a test case per transition. So I have already created a test case for unit test level using the state chart. And then later, as we can see here, if this is a test case, it should be any credit state. This should be overdrawn state. This should be any credit state. So I will go ahead and double check this and see if it will give me this state or yes, no. We have the same issue. We have the same issue. So this is so far an example about test cases for unit test that should be developed by the software tester or software engineer who will take care for this unit test in this case. Again, we have to define the test cases before we'll go to the unit test. And here, this test cases, we have already defined it using the state chart that we have already as a documentation for the system. Integration testing. I said integration testing, it means that we will have more than one unit or more than one class. It's being somehow, you see this. If you remember in the state chart, we will have different state and we have a composite state. This composite state can be seen as integration testing for this composite state. That we have different components, they will be involved in the same composite state. So this is an integration state testing should be done for this. So we have more than one methodology for do this. Big bang integration, all components together, we will do it. Bottom up, which means start from low level to go to the up, and sure, there should be stub tests for needed. From top to down, there is no test drivers needed. Prabjot, are you here? Prabjot, are you here? What about you, Genevieve?
Yes, I'm here.
So, based on what we have already discussed so far, it's okay, Prabjot. When I said test drivers, what I mean?
No test drivers needed.
No, yeah, forget no test. This is when we talk about top-down integration, we said no test drives. But what do you mean by test drivers? I have already mentioned this during the lecture before. This terminology stops, test stops. I have already see you talk about it when we talk about unit test, and this is we talk about it later when we talk about test drivers. So can you help me to tell me what you so far understand from this test drivers?
I think it refers to basically how we integrate testing for our application or software. So
yeah, it's not exactly like this.
So we call different programs in.
Yeah, let's return to here. When you talk about definition of a driver and stub. So driver mean that it is a module will be the data provider for us. Suppose you have a function and will get the input from another function or from an object that holds these parameters. So driver, it will be the driver module is the data source where we get the data to test this unit. The stub, it is a temporary module or a temporary, let's say, function. We created it to get the result for this unit. Because sometimes this unit will not print out the result. The result of this unit will go to another place. So because you are testing this unit, we need to send a data to execute, which is the argument for this, for example, argument of a function. And we have to double check and print out the result to be sure and to double check the result and compare it to the design that we have already designed before to see if it is the result, is the expected result for this data. Because the result will be based on the argument and the input. So the driver, when we talk about a driver module, can be an object that holds a parameter for a value. It can be another function. So in this case, driver, it is a data source, the source of the data of our system. The stub, it is, I said, we use it as a temporary to print out. So here, return back to the integration here. So in the integration, we are talking about different integration. We talk about different unit that will be related to each other. And after we make different unit tests, we will have to see this is the set of this unit. It's working probably with each other. This is, we name it integration testing. We said, if you start from top-down testing, you don't have to have a drivers that you needed to make for this testing. Why? Because if you have a hierarchy between classes or components that we are dealing with, so if we start from the top, then we have already tested it and we executed it to see the whole cycle, how it is working. So we have the source of data. It's not like when we have a standing alone unit, we have to create a data for it because this unit that we are testing expected the data come from another place. But when we make a unit testing, we have to get it manually, the data for this unit. Here, because we are talking about different component, and then this component, let's say we have X and Y. X will give the data for Y. So if we are going to make integration testing, which means that X and Y will be involved in this testing, so X will be executed first because we talk about top-down integration. And since X executed first, we will get the data that Y needed to execute. There is no need for a driver module in this case, like when we make a unit testing. Is it clear, Genevieve?
Yes.
Perfect. Here, for example, you have integration. When I said integration, that means different component, not one component as we said before. So a component can be a class or can be a method. Here, when talking about integration, we will have different components, and there is a hierarchy between this component. Like here, layer 1, layer 2, layer 3, A, B, C, D, E, F, G. Suppose there is inheritance, for example. So here, we will have low-level component usually perform common tasks. So like input, output, repetitive calculation, object-oriented. Yes, this is a low component. And the higher component, they perform more as a controller. So if we talk about Big Bang integration, which means that we will have different unit tests we have already done for each unit. And then we will make testing for the whole cycle between all this unit. This is, we name it integration testing, and we are using Big Bang. Why you are using Big Bang? Because we are doing the whole at each time. So after we make this unit testing whole, and then we go ahead and perform all at a time, and we'll double check the whole cycle how it is. So this is Big Bang testing in this case. Bottom-up integration, not like this. So we talk about bottom-up. So we will test first, we will execute E, then F, then G, then we'll go ahead, B, E, F, G. Then we will go ahead till we reach make the whole cycle. We are sure that this is a whole cycle is working in this case. Top bottom, from its name, we start with A, and then A, B, C, D, and then A, B, C, D, E, F. Sandwich one, it is somehow, it is a homogeneous, is a mix between top down and bottom up, as we can see here. As I said, it is integration between top up and bottom up, somehow in this slide 34, maybe the slide before this. So select a target level. It depends about you, which means that I want to focus more on this target before this or after this. So class clusters, when I have to, because I said this is whatever it is the methodology, top down or Big Bang, whatever it is the methodology that are we using, but it's based on different component, or it is a cluster of component. So if I talk about object-oriented code, I have to choose which component will form an integrated testing. Like for example, if I talk about state chart, I have a composite state, which is from different state. And this different state, they are related to each other. This is why in the state chart, I make a composite state. So the classes they are involved in this composite state can make an integration testing. So if I want to double check the different classes that I want to test within the integration testing, now there is a question, which classes I have to choose? In order to answer this, in object-oriented, this class should be tightly coupled. When I talk tightly coupled, which means that they are more, have, for example, inheritance between them. So let's take this example from use case diagram. So I have a method here, I have a request that will be sent by user interface, and then there is a controller, suppose, whatever it is, a controller class. And then there is a method should be executed here, then the request R, then method X will be done, then method Y. So I can see then there is a result will be returned back. So this is X and Y. Both of them I can make integration testing after I make this unit test and this unit test. So I can see I can make integration testing to be sure that the request that was sent to this composite or cluster of classes will return the result that is taking place. So this is what I mean by integration testing, that which unit tests that we will test with each other. After we will make this unit test, so to be sure that they will be involved in this, which means there is a request, and this request will be sent to two methods to get the output. And these two methods based on the class in two classes. So I will make integration test to be sure that this request will get the result that was expected. So X and Y can form this integration test. Again, when I talk about X and Y, that this result, I said there is an output report. So this is a unit and this is a unit. Both of them will make an integration testing. Or I can, perform integration testing for them. What about the use case? So also, I can see here from cluster class here, from this use case, all this method will be involved in this use case. So this can make also an integration testing that I can consider in this case. So if I want to search, as we can see, searching for integration testing, I can go to the use case diagram and I can have the sequence diagram that I have, or the calibration diagram, but more probably the sequence diagram. So this is the main two part in testing, the unit testing and the integration testing. To sum up, integration, the unit testing talk about the classes and methods. Integration testing talk about different classes or different component, how they interact with each other, and this component will give me the main output that expected from their whole interaction. And how I can define the test cases, again, based on the different diagrams that I have it. So unit test should be done first. Integration test can be done based on this unit test, but the big question would say, which set of classes or components that I can do an integration test for them. I have to return and want to talk about object-oriented different diagrams that I have it. So the sequence diagram and the use cases can help me to pick different components that should I perform integration testing for them. The last point now talk about is more general point or more generic. We talk about system testing. So we have already tested different unit, and we have tested different group of unit using integration testing. So now this is the overall system testing that we are going to deal with it, which means that it is the whole system. The behavior of the system is somehow as a whole is doing what's expected from this. So I have to go to the input and the final output of the system. I will not go inside the system. Is this doing what is expected? Again, what I said at the beginning of this lecture, when I said what is doing as expected, which means that doesn't mean that it has to crash to see there is an error, but it will give me sometimes a result that is not 100% mapped with what I have already planned before. You hear this beta testing, and you hear about alpha testing for the system. We're talking about the whole system. We are not working internally. By the way, people that have to work with such kind of a testing doesn't mean that should be very technical, professional people. If we talk about software and talk about more about the programming stuff, no, they can be normal users. They are more from business oriented. For example, I can ask if I'm making an ERP solution, I will go ahead and ask an accountant, go ahead and double check the state of account of my system as an accountant. He doesn't understand the coding. So he will go double check the general input for the system, make this data entry, and will pull up the state of the charts or the state of the account of the customers and double check manually to see if the system is doing what's this. So here people that be involved normally either will be alpha or beta. So beta will be more, let's say, it's not from our system. You can ask other customers or you can ask the customer himself who is going to use the system, or you can hire them, or you can ask for volunteers for this. This is the alpha testing. So the alpha testing, beta testing, it's more for users that they will not from the whole system or not from the team. Alpha testing, they can be from the team in-house. However, it doesn't mean that they are programming technical people. No, they are not software testers. No, they can understand more the business ecosystem or the business modeling or the business usage of this system. So you are doing a POS for a cashier. So you can ask. So you should have a person if you have a high volume, high scale, which means that you develop huge amount of, you expect to have a huge amount of users they are using. So you should hire somebody that he somehow has understand the whole procedure of what is a point of sale or a cashier employee will do later in order to make this testing in-house. Again, beta testing, it is somehow people from out of the team, they have to do this. And sometimes you can go to the market and release this, and we can see this in different apps. And we say it is a beta testing. Acceptance testing, we talk more about it's somehow whole testing procedure for the whole system. Unit testing finished, integration testing, system testing, beta testing finished, everything was finished. So we said, okay, now everything okay, go ahead and release it for this. But we need to have a huge amount of feedback for different users to see what is acceptance rate for different aspects in the system. By the way, in this lecture, I give the general aspects about testing because I thought, even though maybe according to the book that we are using or according to the main outcome of our course, testing is not part of it. But I believe you should know about it. And it's very nice, as I give more than one example in this lecture, as I did when you map design charts or diagrams with the coding, to understand more why we need to have this chart. It was a good opportunity to understand this. And now you can understand more this charts, how we can use it more in our system to perform different testing and what is the different testing that should be done. So I'm done with the course content. This is the whole content that we have already done in the course. So next lecture or next live session, it will be open for people that they want to make a live presentation. And I encourage all of you, I will send an email about it. All students who have time during the course timing from 10 to Monday from 10 to 12 to make a live presentation, it will be good because I will be with them. So maybe if I can't understand their system or their presentation, I can ask them a question and don't be afraid about the question. I can understand you more to give you a better assessment. However, if you can't be live with me, because it is a synchronous course from the beginning, you can go ahead and make your presentation alone, share me with the video, and it will be in the same day, because the deadline is 6 December. This is why I chose the deadline to be the last day in the course, to be sure that people who can go to it within the live session can do it, and people who can't do it, they have time till the end of the day to send me the final presentation deliverable. So I encourage people who can join the last live session, go ahead and make the presentation within the live session. And maybe in the other live, it will be open also if you have any question about the course. People who is going to join the last live session can ask me. And also I'll be happy to hear your feedback about the course. And maybe I have some discussion concerning the final in this live session. So there is no any material in the course. The next live session, we will have a lecture. However, it will be open for presentation, for questions, and to discuss the final exam, how it will be. Prabjot, it's your microphone is okay now?
Yeah, it's good now.
How are you?
Great. How are you?
Great also. So how your project? You have some progress with the project?
Yes, we do. Like we started redoing the sequence diagram, and we actually finished that. And I guess that was really helpful in the class diagram. So we are more clear now.
Okay.
Yeah.
Perfect. Yeah, you mean that it's more clear the class. You were with me with a virtual office hour, yeah?
Yes, that was our team.
Yeah, this is if you can see, you and your team were a good example for others to understand more why we need this chart.
Yeah.
So maybe some people they say, okay, just it is theoretical part because we have to understand more about the behavior. But no, it helps us to have a good structure for the system, starting from the use cases, passing by the sequence diagram, calibration diagram, passing by the model diagram, till we have the final design class diagram. I think it was more clearer to you now.
Yeah, so now we kind of understand every step or every diagram is important for the next one.
Yeah. Yeah. By the way, this is the main aim from the project. I'm sorry, by the way, that this was a synchronous course. Maybe it's for some student, a synchronous course would be easier for them. Even though, especially for people that maybe they are not physically in Canada.
Yeah.
But even though I'm a classical person because I'm not very old. So, however, I'm in education, I'm more oriented to have a classical class lectures because I believe in education. This interaction in a physical place is the best way and scenario to give a course. By the way, I believe in this.
Yeah.
Maybe somebody who don't believe in this, but I believe in this. My own belief. Amber, concerning final, I said that the next live session we will discuss this more. So far, what I can see about the final, that it will be. Go ahead. If you have any question for me, you can go ahead and ask me.
Yes, sir. Am I audible?
Yeah, we can hear you. Go ahead.
So I wanted to ask, like, it will be a Blackboard paper, like the exam will be on Blackboard only, right?
Yeah.
And
I will
sir,
use a Blackboard for this.
I wanted to ask, like, how many questions will be in there, and what will be the format of questions? Will it be MCQ based or theory or diagram based?
All.
All.
Yeah. First, I can't tell you how many questions it is because I haven't finished so far. I'm still preparing it. So, but what I can say for you that we will have a multiple choice. We will have a true false. So we will have both of them, and we
theory?
will
Theory based?
we will have also theoretical part. I think the last assignment was more theoretical, yeah, as I remember.
Yeah. Would it be similar
So,
to that? The MCQs?
yeah, it will be similar. Yeah, the final exam will be very similar to the assignment, but it will not be exaggerated with many diagrams because you have a time limitation.
Yes, sir.
So you will have a multiple choice, you have a true false, and you will be asked to maybe to draw a small part for diagrams or a part for a diagram. I will be more specified in the final exam. I will not give you very general one and to go from different diagrams because you have a time limitation. I will to double check that, yeah, if there is, yeah, I think that I will double check also this, if using Blackboard you can upload a document.
Okay.
As you do in the assignment, in order that some people that they will not, maybe they will draw using handwriting and they can upload the image. It will be easier maybe, or some people they will use their own to do it. I will double check for this more about Blackboard, but so far what I can tell you that all material is being included, and we will have a theoretical part, but like the last assignment, multiple choice. When I talk about theoretical part, it will not be comprehensive that you want to answer using writing tests. No, I will not do this. You will have multiple choice, you will have a true false. I am not a person that will give also for concerning grading. I will not give some exams will give you if you will give an false, you will lose grade from the positive. No.
So
Don't
there'll
worry
be
about
no
it.
negative marking, right?
No negative marking, no.
And sir, so you mean to say that we'll have true, false, and MCQ in theory and other diagrams. We'll not have to write up the solution like in a big paragraphs or so.
No, you will not have this. I will
Okay,
not
sir.
ask you to write a paragraph. So the theoretical part will be only multiple choice and true false in this case.
Okay. And thirdly, we'll have to make some diagrams or upload them.
Yeah,
Whatever.
yeah. But more detailed, I will have it for the next week because I will finish. I'm planning to finish this week the final exam. In order that I will have a more clear image for you for the next week. But you should now, because you should, if you want to start preparing for the final exam, the first point, I will set all the materials included, the whole 11 lectures included. Yeah, 11 lectures are included. 2, we will have a multiple choice and true false theoretical one, so you should understand more the theory about in different what we have already discussed in the lecture. 3, you will have some diagrams that you have to deal with it, but it will not be sophisticated and somehow writing like a project or an assignment because you have a time limitation.
Okay. And sir, will we have sufficient time to complete the examination? Like, what happens is, like, in most of the subjects in the final exam, we always run out of time.
How long you will have this exam? 2-3 hours?
3 hours. It is a 3-hour exam.
I will tell you something about why most of the instructors they have to do this. I will do my best not to go to this, but why? Because they have their own reason. The point that because we have an online exam, it is not in-campus exam, and many of the resources is open to the student. And so for some student will say they don't have to go to prepare well for the final exam, and they will go like this. In my experience, this 2 years, because we are giving online courses for 2 years now. So most of the students, what they do, they go ahead, pick the question, Google it, and then they search for an answer or a similar answer, and then go give an answer. So many instructors, they will make, let's say, a strategy that to give a huge amount of a question in order not to have time to go and search. Who will have the answer will give the answer. You get why this?
Yes,
why the strategy from the instructors? So there is a reason for this, because, for example, you will have a multiple choice exam about 200 questions for 3 hours.
So
because
this is not feasible at all, but not the same position for all.
We will not have this. No, we will not have this. Don't worry about it. In this exam, I will not have this.
Thank you, sir.
Because for me, having this sketch to draw it. So even if a student will go to search online, he will not find a solution.
Absolutely, sir.
So he has to has already prepared well, and he should have already have well understanding before he go ahead and give the solution. But I want to be sure for all of you, and I want to give you an advice. Prepare well for the exams. Don't consider that will be an open book, because an open book, I can't make any control about you. I can't control in these 3 hours when you make the exam.
How you make the exam.
Yeah, what you are doing at home. So, but prepare well. Don't waste of time by considering that I can go ahead and search for, because sometimes searching for the solution, it will take more time if you think about the solution.
Yes, sir. Absolutely. And sir, one last question. Like in the quizzes, I have seen, like if we are doing a particular question and moving ahead, then we don't have any option to go back and check that answer again. It is automatically submit, and we cannot turn back on the previous question.
This is using Blackboard?
Yes, sir. Like in the quizzes, we used we tend to give the quizzes like this. But sir, in the exam, we would really appreciate if we can jump to the forward questions and we can come back just to revise it, because there are sometimes like we are not sure in a particular question in the solution, and we think that we'll do it afterwards.
Yeah, based on discussion with other instructors, there is a reason for this also, because some student, what they will do, they will start answering what they have, and then they will communicate with each other and to see what they have or what they don't get the answer, and they will get answer from each other, then they will go back and put the answer.
No, so that is not the same for all. Like I told you,
yeah, I know.
Sometimes what happens with me,
I'm just giving you the reason why they have to do this. What I will do again,
I tend to complete the answers and topics which I'm pretty good at. So I would really.
I believe that a student, I don't believe that I don't believe in this strategy that I have to make so much restriction. Okay. Because for me, who has to work, he has to work, and even though he hasn't worked, it's up to him. He hasn't to work, and
yes,
if so, and this, especially like 300 course like this, you need this to when you go to the industry later. So I will deal with you as more responsible person. If you want to learn, go ahead and learn. If you don't want to learn, it's up to you. Absolutely. So I will not make so much restriction.
So we can.
I will double check. I will double check in the Blackboard what is the restriction that we will have, and if I can go to less restriction, if I can go to less restriction, I will go to less restriction. Don't worry about it. Sure, but again, I will double check with the settings of the Blackboard what settings I can play around it in this, because maybe sometimes there are settings that I can't avoid it. So, but what I will promise you now, that I am not a person that I believe with restriction. I will believe that it's up to each one based on what he want to learn.
Absolutely.
So it is a responsibility of you. It doesn't mean that you think that you are a clever person, that you get a good grade, and this grade doesn't give an image about what really your own knowledge in this course, but
Yes.
you lost an opportunity to enhance your
The
knowledge in
main
your
part is what we are grasping through this subject, not just passing the course.
Yeah. By the way, this is why the main aim from the project. I said to the project that I need to see the presentation, because from the presentation, I can understand or can make an assessment for the knowledge of each one of you. And I said in the presentation, there's a must that all group members will be involved in the presentation. To be honest with you, any instructor have an experience from the first minute can feel and can see how this student has already benefited from this course and how the effort he has done. You will see later.
Sure.
So if I can watch the presentation, I can know this guy has already made a huge effort, because he can talk about what he has already done in a very simple way, in a very clear way, in a very easy way. So because this person, he has a solid background about the course. So this is the main aim from the presentation. It helped me to give an accurate assessment for all of you in this case.
Sure, sir. Thank you.
Yeah. So take care about the project. The project will be 40% from the course. We have 3 assignments now. So 3 will be 30, and the project will be 40. So the project will be more than the final. So it's very important to consider the project, how you will do, the deliverable, and the presentation. The presentation is a very important parameter for me. Okay, guys, so do you have any more questions for me? Again, if you can join the live session, the last one for you, and later who is going to watch this video, go ahead and do it. It will be a good opportunity to present your work with me. And again, if you can't, it's okay. You can make your presentation and share the video later for me, but it should be done in the 6th December. It is a firm deadline. It is a firm deadline. No excuse. You should send the deliver of the project. Prabjot, Amber, and Genevieve, thank you to joining me today. If you don't have any more questions, give me 2 thumbs up to leave today.
Thank you so much.
Take care. See you.
Thank you, sir.
Thank you. Take care.